In this video, we're going to look at types of reactions. Recall that there are 5 kinds of reactions, or 5 ways to classify reactions that we've looked at in this class. Not all reactions can be classified in one of these 5 ways, but many can. The first are synthesis reactions, where we have the general formula A plus B yields AB. Next are decomposition reactions, where we have some compound AB yielding A and B. We have combustion reactions, which oftentimes take on the form of some hydrocarbon reacting with oxygen to make carbon dioxide and water. A single replacement reaction, where we have a metal reacting with an ionic compound and displacing the metal ion to form a new ionic compound. And then double replacement reactions, where we have 2 ionic compounds where the cations and anions will switch what they're paired with. In all these cases, we want to follow 3 steps for completing these reactions. Establish the reactants, predict the products, and then balance the equation. The first reaction we encounter says calcium and iodine are allowed to mix. If we establish the reactants, we have calcium and diatomic iodine. With just 2 reactants, the only thing they can do is combine together in a synthesis reaction to make calcium iodide. Here we need to establish the correct product. Iodine has a charge of -1, calcium +2, so we'll have 2 iodide ions to balance out the calcium ion. Our reaction is already balanced, so we're finished. The second reaction reads zinc metal is added to a solution of copper 1 sulfate. To establish the reactants, we have solid zinc metal being added to a solution of copper sulfate. Copper has a +1 charge, sulfur a -2, so we need 2 coppers to balance the sulfate. This looks like a single replacement reaction, so we can predict that the zinc and the copper will switch places. That is to say, the zinc will displace the copper. That will yield solid copper and zinc sulfate. Zinc ions have a charge of +2, sulfate a charge of -2, so that's balanced. Now we just need to balance the equation. There's 2 coppers on the left, and now 2 coppers on the right, and it's balanced. Our third reaction reads, when heated, magnesium nitride decomposes. Magnesium nitride. Magnesium has a charge of +2, nitride -3, so we'll want 2 nitride ions and 3 magnesium ions for a total charge of +6 and -6. That decomposes into solid magnesium and into nitrogen, which is diatomic. Finally, we need to balance the equation. Note here that the nitrogen that's by itself, N2, really is 2 nitrogen atoms bound together in a single molecule, whereas the N2 that's part of magnesium nitride is 2 distinct N-3 nitride ions. So even though they both have the subscript 2, they're very different. The N2s are very different. Our next reaction says solutions of potassium phosphate and magnesium nitrate are mixed. First, let's establish our reactants. Potassium phosphate and magnesium nitrate. Here with 2 ionic compounds, we know we're dealing with a double replacement or double displacement reaction where the potassium and the magnesium will switch places. That will give us potassium nitrate and magnesium phosphate. Now we need to balance the equation. We have 2 phosphate on the right, so we could try 2 phosphate on the left. That'll give us 6 potassium, and that gives us 6 nitrate, so 6 nitrate. As a check, 3 magnesium and 3 magnesium. Our final reaction reads, propane burns in the presence of oxygen. Burning indicates this will be a combustion reaction. Likewise, we have both a hydrocarbon and oxygen, further signaling this to be a combustion reaction. The products of combustion are always carbon dioxide and water. Now we just need to balance the equation. 3 carbons on the left, 3 carbons on the right, 4 hydrogen on the left, 8 hydrogen on the left, 8 hydrogen on the right, and then a total of 10 oxygen on both sides of the equation.